Have you ever wondered how a tiny component, literally smaller than a grain of rice, can actually protect your entire smartphone from just completely dying? Well, welcome to today's explainer. We're going to break down the microscopic components inside your smartphone, specifically focusing on the mighty, underrated resistor, and we'll learn the basic skills you need to actually diagnose and replace them yourself.
Okay, let's dive into this question right off the bat because, honestly, with rising repair costs, so many of us are wondering if we can tackle phone problems right at home. I mean, it can seem incredibly intimidating to crack open a device that costs $1,000, right? But with the proper approach and a little bit of knowledge, the answer is a resounding yes. It's absolutely worth it. Not only is it going to save you a ton of money, but it builds a genuinely useful skill set.
So here is our roadmap for today. First, the DIY repair toolkit. Second, inside the smartphone motherboard. Third, identifying surface-mounted devices. Fourth, the multimeter, your stethoscope. Fifth, component testing guidelines. And finally, number 6, soldering and replacing parts.
All right, let's get into section 1, the DIY repair toolkit.
To handle delicate phone parts without causing a massive short circuit or, ugly cosmetic scratches, you really only need a handful of affordable tools. You need plastic pry tools, and those are vital because metal can easily scratch the frame or worse, short out a battery. You'll also want a suction cup to safely lift the screen and a pair of anti-static tweezers for handling tiny internal parts without randomly zapping them with static electricity. But your absolute most important tool is this, a precision screwdriver set. Smartphones are held together by tiny, incredibly specific screws. So you'll need a set featuring tiny Phillips, flathead, Torx, and Pentalobe bits, which, by the way, are the ones specifically used for iPhones. Oh, and definitely look for a set with magnetic tips. Trust me on this one. Losing a screw the size of a breadcrumb is a headache you absolutely want to avoid.
So a crucial point before we go prying open a phone is just knowing your limits. A basic toolkit perfectly empowers you to handle things like battery swaps, screen replacements, or changing out charging ports. But as a beginner, you should really avoid advanced motherboard-level repairs and integrated circuit or IC replacements until you've mastered the basics. That said, today, we're actually going to peek ahead at those advanced skills anyway.
Which brings us to section 2, inside the smartphone motherboard. When you look inside a smartphone, you're not going to see those traditional clunky electrical parts with long wire legs sticking through holes. Modern phones rely almost entirely on SMDs, or surface-mounted devices. These are microscopic, highly efficient components soldered directly onto the flat surface of the printed circuit board. Just look at the sheer density of these microscopic components here. It's like a sprawling microscopic city. Every single millimeter is utilized. Hundreds of these SMDs are packed into distinct sections to handle everything from power management and battery charging all the way to your Wi-Fi, audio, and display.
Let's move to section 3, identifying surface-mounted devices.
Okay, this is where it gets really interesting. Notice how a capacitor is usually light brown and an inductor is often white or ash-colored. But I want to really focus on the resistor today. Visually, it's the one with the black center and silver soldered edges. Now, to understand how this works, imagine electricity as water flowing through a pipe. The resistor acts exactly like a valve that controls how much water can pass. It doesn't stop the flow, it regulates it. And it does this on an atomic level. Inside the conductor, electrons are moving between atoms, and resistance happens when those electrons collide with the atoms, converting a tiny bit of that electrical energy into heat. If just one of these tiny black chips burns out and breaks that flow, it can completely prevent your phone from powering on or charging. It's literally the small component that controls the entire electrical ecosystem.
Now for section 4, the multimeter, your stethoscope. I absolutely love this analogy from our source material. A doctor uses a stethoscope to listen to your heartbeat, right? Well, a mobile repair technician uses a multimeter to listen to the heartbeat of a seemingly dead mobile phone. It is the definitive way to figure out what's happening invisibly inside those microscopic circuits.
Whether you choose a sleek modern digital model or a classic analog model, this tool is non-negotiable. It allows you to check voltage, test for continuity, which basically means making sure a circuit is unbroken, and measure resistance. By using the probes, you can instantly see if a line on the motherboard is live, dead, or if it's short-circuiting.
Let's look at section 5, component testing guidelines.
So how do we actually test it?
Well, you simply place the multimeter probes onto those silver edges of the SMD. Say we're testing our resistor. We want to measure its resistance. The multimeter sends a tiny, completely safe amount of electricity through the component, measures what actually comes out the other side, and then displays the result right on the screen. Following these exact steps is absolutely critical. First, you change the multimeter dial to the ohm range. That's the symbol for resistance. Then, carefully touch both ends of the component. If we are testing a resistor, you compare the reading on the screen to its expected factory specification. If it reads totally open, like infinite resistance, that means the resistor is severely damaged, burned out, and basically broken inside. On the flip side, if you're testing something else, like a vibration motor, a reading of 0 ohms indicates a dead short, meaning the part has completely failed.
Finally, Section 6, Soldering and Replacing Parts.
Now we get into the real precision work. First, you safely disassemble the phone and remove the delicate motherboard. Then, you lock the board securely into a specialized PCB holder. This is non-negotiable. You absolutely cannot have the board slipping or shifting around while you're working with microscopic parts in incredibly high temperatures.
Next, we actually ditch the traditional pointed soldering iron for a hot air gun. You carefully direct a stream of highly controlled hot air right onto the specific faulty component. The goal here is to gently melt the tiny silver solder joints holding the bad component down, but without accidentally melting all the healthy components surrounding it. Once that solder becomes thin, shiny, and fully melted, you take your anti-static tweezers and gently lift the bad component right off the board. It requires a super steady hand. Then you apply a little bit of flux paste, grab a brand new, healthy component, like a fresh resistor, and precisely seat it right onto those molten solder pads.
So, here's the complete professional replacement loop. Apply flux to help the solder flow nicely, apply directed heat to melt the joints, remove the old component, and carefully seat the new one. The second you pull the heat away, that solder solidifies almost instantly, literally bringing a damaged, dead circuit back to life.
We have covered so much ground today. We've gone all the way from basic budget screwdrivers to understanding the atomic level resistance of a tiny black SMD chip, and finally to the intense precision of hot air micro soldering. Repairing your own tech is just so empowering. So I'll leave you to consider this. Which broken device, currently sitting forgotten in your drawer, are you going to revive first? Thanks for joining me on this explainer, and happy fixing.